Hello everyone, this is Nostradamus, and in this video presentation I'm going to be discussing a major discovery I've made about direct correlation between the atmospheric carbon dioxide sequestration and the ONI El Nino La Nina oscillation. Basically it's about how much the land and the sea absorbs CO2 over the past 20 years and how it relates to the Pacific Ocean sea temperatures. So don't expect any fun and games in this video. You'll have to wait till my next one when we can all have a good laugh at how bad the methane levels are getting. I'm going to start by talking about what led me to this discovery in the first place. I'm going to show you the where I've collected my data from, the calculations I've made, and the end result, which even surprised myself, just how good a fit the graphs are when I finally put them together. As most of my regular viewers will probably know, I'm an avid fan of Environmental Coffee House. You know, the one with Sandy Shellers and Jennifer Hines, my two favourite Doomer chicks. And if you don't watch it, well, you should, because they're great. And they often have on Jim Massa as a guest. Now he's an oceanographer, and he's way more intelligent than I am. But recently, quite a few times, he's mentioned about what will happen if the oceans get saturated with carbon dioxide and they start blowing it out rather than absorbing it. A real doomsday scenario. So my intent was to try and estimate how long in the future would this disaster begin to unfold. The amount of CO2 that the oceans can withhold, or indeed keep taking in, depends on many complicated factors. The main ones being sea surface temperature, salinity of the water, how well the plankton growth is doing, taking in the CO2 and giving life, giving oxygen to the planet, the overturning of the oceans, dependent on ocean sea currents, and whether they're slowing down, as recently reported. As I mentioned, there are many other factors as well, and it's just way too complicated to study. So I thought I'd try and take a simpler approach, and I looked at how much CO2 is being emitted each year in gigatons, and how much CO2 is going up annually, and try and work out the difference to see how well the planet, land and sea, how well it's doing at absorbing it. And I'm now going to show you what I did and show you the results at the end. I hope you enjoy it. So here's where I began. I wanted to find a nice simple conversion unit to use in my calculations later on, which I knew I would need. So I've just found this random website where it says, and it doesn't matter when, this is from 2007, go for any year and the division should come out the same outcome. We've got approximately 3 times 10 to the 12 tonnes weight of CO2 in the atmosphere at that time. And at that time, the Earth's atmospheric CO2 concentration was about 383 parts per million. So when you do the calculation, that 1 part per million, each and every 1 part per million of CO2 in the atmosphere weighs 7.83 gigatons. 7.83 gigatons. Okay? So next, I went to Our World in Data to look at CO2 emissions. Now I think these are just human emissions. Doesn't include volcanoes and the like. Where I think volcanoes are negligible compared to anthropogenic emissions. It's all estimations and approximations, because this certainly is not an exact science. For the purpose of this video and showing you how I did my research, I'm just going to pick 2012 as a random year. So as you can see, in 2012 the annual CO2 emissions worldwide was 34.8 billion tonnes. I recorded the figures for each single year from 2000 through to 2019 and an estimate of last year 2020. I recorded these numbers here in column B, gigatons of carbon dioxide added each year anthropogenically. I then visited this site, Statista, to examine the annual CO2 concentration in the atmosphere. As you can see here, in 2012 the CO2 concentration was way down at 393.9 parts per million approximately. And what I did, I worked out the difference between each year from 2000 to 2020, the difference between each years, to find out the annual increase in atmospheric CO2, which I recorded here in column C. And in 2012 it was 2.2 parts per billion higher than the previous year in 2011. Then, using the formula I worked out before, that 1 part per billion equals 7.83 gigatons, I converted the annual rise in parts per million into how much extra CO2 was in the atmosphere each year in gigatons rather than parts per million. So now, if we take how much extra there was in, let's do 2012 for example, there was 17.2 gigatons more CO2 in the atmosphere than there was in 2011, but 34.8 gigatons was added to the atmosphere by humans. Therefore, the planet absorbed the difference between the two, which is 17.6 gigatons. So if we divide that back by 7.83, the conversion unit, that means the planet absorbed 2.2 parts per million's worth of CO2 in 2012. From these figures, we can work out the total percentage of all the carbon dioxide in the atmosphere that was absorbed back by planet Earth year by year. So for 2012, the atmospheric CO2 level was 393.9 parts per billion, so there was 396.1, of which 2.2 got sequestered. So that means 2.2 as a percentage of 396.1 comes out at 0.57% of all CO2 in the atmosphere in 2012 was reabsorbed by planet Earth. Now we all know the amount of CO2 in the atmosphere is increasing annually, year on year. But the past decade, we can see that it's an exponential growth. The annual rises are higher than what they were in previous times. But as I was comparing the data, it just jumped out at me. The anomalously high reading at 3.4 parts per billion jump from 2016 over 2015, it just clicked. Wasn't that an El Nino year? So that got me a bit intrigued. So I decided to follow the path of the El Nino La Nina oscillation. I began to wonder, could there be a connection? So I took the column H, which had worked out the percentage of the total global CO2 in the atmosphere which was removed each year, and I decided to compare it to the El Nino La Nina oscillation. Some of these figures have diverted by 0.01 in roundings, but it's negligible. Right, I'm sorry if this looks a bit complicated. I'll try and explain. So column B here is the previous column I showed you on the other sheet. It's basically showing you how healthy the planet is doing at absorbing the CO2 that we're putting out. The higher the number, the better the planet's doing at absorbing the CO2, and the lower the number, then that means that not so much CO2 is being absorbed. Over in column F, I've colour coordinated it so it's easy for you to visualise. In red are the strong El Nino years, orange are the weak El Ninos, the blue are strong La Nina years, and the turquoise is weak La Nina years, and the zeros in white are neutral. As you can see, I've given each one a value dependent upon the strength and the phase each year, and I've given them values of -1 to +1. Now I know that for a comparison on a graph. I've converted all the percentages of global CO2 absorbed by the planet into a range from -1 up to +1, all in proportion. So as you can see, the planet didn't have a very good time of absorbing CO2 in 2003 and 2016, when it was just 0.27% of all global atmospheric CO2. In 2003 we had a strong El Nino. In 2016 we had the strongest El Nino in human history. On the opposite end of the spectrum, the highest value was in 2011, where the planet did quite well at absorbing the atmospheric CO2, which just coincidentally that year we had a strong La Nina. So going to 2012, which I picked at random at the beginning, you can see that the planet did pretty well at absorbing CO2, 0.56%. And when we convert that onto the scale of between -1 and +1, it comes out pretty high up at 0.49. And that just happens to be a strong La Nina year. I do hope you're following me up to now, because now it's time for the graphs. So when we plot the CO2 planetary absorption rates against the ONI oscillation strengths, lo and behold, we get an extremely strong correlation between the two. So now it looks pretty obvious that the El Nino-La Nina oscillation has a pretty large effect on the planet's ability to absorb carbon dioxide from the atmosphere. Obviously, El Nino raises the temperature of the oceans and the land. So as the temperatures rise, the ability for the planet to absorb CO2 decreases, which will only get worse in the future as the temperatures continue to rise. But what I've done next is, what would the Earth's ability to absorb CO2 have been without the influence of El Nino and La Nina? So I have adjusted the percentage for each year of how much CO2 has been absorbed annually, and I've adjusted each year to make them as though they was all neutral years and there's no El Nino and no La Ninas at all. I do think this graph is very telling. Now, to be honest with you, I was expecting this graph to be flat-ish, but there's many bumps and jumps along the way over the past 2 decades. As you can see, the planet's ability to absorb CO2 was below average as we've gone through from 2004 through to the year previous to El Nino, 2015. The planet's been absorbing more CO2 than previously. So obviously the vegetation's been doing well, loving the CO2, sucking it up. The plankton in the sea's been absorbing it, growing, sucking it up. and I think that explains why the graph is showing peaks. It's just in the last few years the graph seems to be declining, and that's an extremely worrying sign that the planet's beginning to lose its ability to absorb the CO2 in the atmosphere. So now for my grand finale, my pièce de résistance. Going back to the earlier graph, let's just focus on the El Nino year of 2016. That's showing that the El Nino and La Nina index is upside down here, as I told you earlier. So we had a strong El Nino, which gave an index of -1 with the red line, which correlated with a very low 0.27% absorption rate of CO2 in the atmosphere. You can see the CO2 absorption dipped during the strong El Nino in 2016. So what I've done here, I've flipped the CO2 absorption rate. I've inverted it. So the higher the line, the lower or the worse the planet is doing at absorbing CO2. So I then decided to try and superimpose this graph that I made from data I collected and calculations that I'd made onto the official NOAA ONI index graph. Never in my wildest dreams did I expect such a perfect fit. Just look at that. So that concludes my presentation. Thank you all for watching. If you enjoyed it, please like this video. If you loved it, please subscribe and share. The next El Nino could be quite interesting. The oceans may even start outgassing. What do you reckon, Jim? Cheerio.